All right. Hello, friends. So today we are going to take a very quick look at some of the searching algorithms in Java. Searching is one of the most important and popular algorithms in any context or programming language. And the reason why we are learning about this is that it's almost used everywhere, right? We are going to take a look at some of the fundamental techniques of search and also going to appreciate the difference between them, right? All right. So the first thing that we are going to take a look at is, how the linear search works. This is also known as, the brute force way of searching. We are going to take a look at how it works, and then we are going to take a very quick look at, one of the code snippets of linear search. Then we'll jump over to binary search. We are going to take a look at how binary search works. We are going to take a look at the code of binary search, and then we are going to talk a little bit about conclusion. Super short video, but extremely helpful. Let's do it. All right, let's take a look at the linear search. Now, in case of a linear search, each element of an array is retrieved one by one in a logical order and checked whether it is the desired element or not. Let's take an example. Now, in this case, we have a list of elements present in the memory. Let's say we have a bunch of integers, and we have to search for 20. In case of a linear search, we will traverse through the whole list one by one and compare the value of each element present in the list with the element that we are searching for. As soon as that element is found, we will stop the search and return the index. So overall, it's a pretty straightforward way of accessing elements. You just iterate through the entire array size one by one, and as soon as you find that element within that array, you return the ith element, or otherwise you just return saying that you were not able to find that element, right? So this is the most simple way of searching. It's almost a sure shot way of searching an element in the array if it is present there, and just a simple for loop. Linearly it is going to search, and it is going to return if you have that element present in that array. So overall, it's a pretty straightforward way of accessing elements. You just iterate through the entire array size one by one, and as soon as you find that element within that array, you return the ith element, or otherwise you just return saying that you were not able to find that element, right? So this is the most simple way of searching. It's almost a sure shot way of searching an element in the array if it is present there, and just a simple for loop. Linearly it is going to search, and it is going to return if you have that element present in that array. All right, now let's take a look at the binary search. Now, the binary search is an extremely efficient algorithm. The search technique consumes less time in searching the given item in minimum possible comparisons. Now, one important thing is that to do the binary search, we have to sort the array elements. Now, this increases the time taken by any algorithm, but we will talk about that later. Let's look at a little bit, the logic behind the technique. Now, in case of a binary search, first of all, you have to find the middle element of the array, right? The middle element of the array is compared to the element to be searched. There are three cases that could arise, right? If the element is the required element, then the search is successful. When the element is less than the desired item, the search only the first half of the array. If it is greater than the desired element, then search in the second half of the array. Now repeat the same steps until an element is found or it exhausts in the search area. In this algorithm, every time search area is reducing. Therefore, the number of comparisons is at most log n plus 1. As a result, it is an efficient algorithm when compared to linear search, but the array has to be sorted before doing the binary search. All right, let's take a look at the implementation of a binary search algorithm in Java. So don't really worry about the return type int or the keyword static in this case. The intention is to just try and understand what this method binary search is doing. So it also, just like linear search, it also has like three parameters. We have S, which is the element that you want to search. We have the array, and we have the array size, right? So we are taking a couple of elements. We are initializing them. We are taking start, and an array size we are keeping to -1, and we are taking one element as mid. So these elements are the reflection of the algorithm that we just saw, in our previous slide. Now here is the fundamental algorithm by help of which we do binary search, right? So this is just the pre-check. We have to make sure that we haven't reached the end of the element or the array. Sorry, we haven't reached the end of the array in this case. So what we do is we use the variable mid and we assign the value of end plus start by 2, right? So because we have taken it as an integer, so it is not going to have any boolean value. So in case if it's an odd number, if you do end plus start, and if it's an odd number, then it will simply ignore the odd number, which means it will take the lesser of like min of the value which comes out after calculating end plus start. Right now, if your array mid is less than S, which is the search element that we are trying to search for, then the start element is moved to the middle of the list that we are looking for. Otherwise, the end is moved to the middle -1, right? So this is the fundamental technique that we use. If we are not able to find that element, then, and if the element is greater than the middle of the element, then simply move the start to the middle of the list of the elements, or move the end to the middle, right? So in both the cases, as you have seen in this diagram, if you're sort of looking for any of this element, then what do you have to eventually do? Like in this case, we are searching for 23 here. So we just simply calculate what is the middle element here, which is 16. You move the start to 16 and then start searching from 16. So in every iteration, what is essentially happening is we are reducing the number of elements through which we would traverse to half. This is an extremely efficient algorithm, and that's why the binary search has this log n plus 1 as a runtime complexity. We will learn a bit more about runtime complexity in our later classes. How do we denote runtime complexity and so on. But for now, this is what we are focusing on: binary search implementation. All right, thanks. All right. After looking at both the linear search and the binary search, let's just focus on some of the key differences between the linear search and the binary search. The very first thing is, like, linear search is iterative in nature, right? And it uses sequential approach. On the other hand, binary search implements divide and conquer approach. The time complexity of linear search is O(n), while binary search has O log n, right? The best case time in linear search is the first element, that is O(n), as against in binary search, it is for the middle element, that is O(1). In the linear search, worst case for searching an element is n number of comparison. In contrast, it is log n number of comparisons for binary search. Thank you very much for listening to this tutorial. I hope you guys were able to understand the difference between the linear search and the binary search and the search algorithm. I hope to see you all soon again. Thank you very much.